ahead. Good evening, everybody. Can you all hear me?
Yes.
Can you hear me, John? Good.
Yes.
Okay. Tonight we have John Amos, who was the founder of a nonprofit called SkyTruth that operates out of West Virginia as a group of consultants. And SkyTruth uses remote sensing techniques to monitor environmental and other environmental deterioration of human causes and other causes on the ground and put the word around. John has a very long background in remote sensing. I worked with him back 45 years ago, I think it was, at Earth Satellite Corporation in Washington. And I've forgotten exactly how old SkyTruth is, but it's over 20 years old now, and has had a very long and successful career at identifying issues and mapping them. And right now he's working on something that's very dear to my heart, and that is trying to automatically classify the origin of oil slicks. And the last 10 years I worked in the oil industry, I was mapping natural oil slicks all over the world, and my big problem was separating oil slicks due to seepage on the seafloor from slicks due to boats pumping bilge, and from slicks due to the algal blooms on the sea surface. So with that, I'll give you John right here. So John, it's all yours, and share your screen.
Thank you very much, John. And as John said, we've got a little mutual history. We both kind of started out, cut our teeth in remote sensing for geologic resource exploration at a company called Earth Satellite Corporation in Rockville, Maryland. John, I'm a little depressed. I'm not as old as you think I am. You were there in the 80s and swapped out to go to Shell, and then I came in the 90s. And then I started SkyTruth in 2001 after learning how to use satellite imagery for basic geologic mapping under the tutelage of fairly harsh clients like John Barry when he was at Shell. I should say demanding clients. So thank you for that education, John. I hope I'm using it wisely and well now. And thank you all for joining us for this little webinar today. I was really very pleased and flattered when John reached out to invite me to give you all a kind of an overview of my nonprofit organization called SkyTruth. And this is an organization that I founded to try to share the view from space with everybody who cares about what's happening down here on planet Earth, in the sort of naive hope that seeing is believing, that when you show people the things that are happening, it will register a little bit more deeply and perhaps a little bit more emotionally than just telling them about the things that are happening. And then maybe that'll help motivate people to get up off the couch and do something about it. So I'm going to give you kind of a whirlwind tour of SkyTruth and the things that we do. I want to start at the beginning, at least what I think is the beginning. This is actually a photo of a captured German V2 rocket at White Sands Proving Ground in New Mexico, not far south from where I'm sitting right now on the outskirts of Santa Fe. At the time this picture was taken in October 1946, my father was a technician third class in the US Army, and he was assigned to a crew to track the test launches of these V2 rockets. It was the beginning of the Cold War, and we were actually attempting to try to figure out how to provide guidance systems so that these things would hit the targets we wanted them to hit. And one of the aspects of that test program was engineers strapped some cameras to the outside of these rockets And one of the launches in October 1946 crashed back down to Earth. The camera survived, and it contained what researchers now think is the first photograph of the Earth taken from space above an altitude of 60 miles. And here it is in all its glory. I think this marks the start of the Earth observation era, and certainly the start of the space race. And of course, we humans have been very busy launching things into orbit around the planet. Hundreds of these orbiting satellites are actually Earth observation satellites, like this constellation that NASA operates. Satellites that have instruments on board that are pointing back down at Earth and collecting pictures and making measurements and collecting other forms of data to educate us about how the Earth's systems are changing and responding in response to natural variations as well as human pressures. Here's a picture of one of my favorites. This is the Sentinel-1 satellite operated by the European Space Agency, which is a radar satellite. So not only do these satellites collect pictures using visible reflected sunlight, they also operate in wavelengths that the human eye can't see, which is often more powerful for providing information about things like, in the case of radar imagery, oil slicks out in the ocean, among other things. So I started SkyTruth back in 2001 as my personal instrument to give me a job doing what I wanted to do, using remote sensing to explore environmental issues, and also to provide a vehicle to recruit others to this approach. And we're not campaigners, we're not Greenpeace, we're not Sea Shepherd. We don't make a lot of noise. That's by design. We feel that a lot of the credibility of the images and data we produce comes from not having too loud a dog in the fight. But we are definitely motivated by conservation to do the work that we do. But we rely on others, citizens groups, conservation advocacy organizations, large and small, government agencies, and scientific researchers to take the work that we produce and turn it into real impact out in the world. And we are a small but mighty organization. As John said, our headquarters is in Shepherdstown, West Virginia, in the outer orbit of Washington, D.C. I'm actually based outside of Santa Fe, as is our CTO. We have a vessel tracking analyst who globetrots. He works from Europe. He works from Peru. He's occasionally in Shepherdstown. So we really are a diverse, geographically diverse and increasingly far-flung organization. But Shepherdstown is where the office space is and where the beating heart of the organization still resides. We've had some funding success lately, so we expect to grow from our core of 13 full-time employees now to about 19 to 20 by the end of next year, mostly hiring computer programmers, data scientists, and remote sensing specialists and image analysts to build the team. If you know us, you know we've got a bit of a watchdog reputation. We've used satellite imagery throughout the years to occasionally call people out on the things that they're telling the public, providing visual evidence and measurable, quantifiable data to refute some statements made by governments and industry. Given my background, I've been especially interested in exposing some of the collateral damage from fossil fuel exploration, development, and transportation as a way to alert people to things that they may not be seeing or hearing in the conventional media. Having said that, we've done a pretty outsized job for a small organization at attracting national and international media attention to the issues that we've worked on. And it's not just fossil fuels. Our satellite toolkit is diverse and growing by leaps and bounds, and allows us to work on a wide variety of environmental issues. For example, overfishing exacerbated by illegal fishing out in the middle of the ocean. So I'm going to just show you a few examples in a little bit more detail of some of the things that we've done. Certainly an issue close to home for those of us living and working in Appalachia is coal mining, particularly mountaintop removal mining, which is essentially coal mining on steroids, where the top strata overlying the coal deposits are blasted and removed and pushed off into the valleys on either side to expose the coal seams for highly efficient mechanized removal of the coal. Here's an aerial example of one of the larger mountaintop mining operations in West Virginia called the Caford Mine. If you get up in the air a little bit, here's aerial survey photography showing what that mining operation looks like. The bright patches that are superimposed against the still intact green deciduous forest of these high biodiversity Appalachian hills. Stepping back even further using satellite imagery, the red insight box shows the previous view, and all of those colored polygons represent mountaintop mining operations that our team has detected and mapped using decades worth of Landsat satellite imagery. And this slide also illustrates one of the powerful tools that we use to be able to do the work that we do and make it scalable, even global in scope. That's the Google Cloud Platform, in particular, a tool called Google Earth Engine that gives us and you and anyone else who wants free access to millions of satellite images stored in the Google Cloud. And it's a toolkit that allows us to write very sophisticated analytical algorithms and models, implement those in the cloud rather than on our desktop computers, and get results nearly instantly from the Google servers. And that is something that allows us to really do work at scale on issues like this. One thing this work in particular allows us to do is annual analyses and year-over-year comparisons. And that allows us to actually map in fairly precise detail how much new land is being directly impacted by surface coal mining and exactly where it's happening. This allows us to compare with mining companies' permit boundaries. We've already found a couple instances where mining companies have mined beyond the approved permit boundaries. It also allows us to provide very useful data, geospatial data for scientific research. About 10 peer-reviewed publications have been written by us and other researchers using the data that we've produced and make freely available to the public on our website. One of the first papers was this one. And one of the outcomes from this paper, which quantified the downstream contamination of drinking water sources, was that EPA decided to take action it had never taken in its history to overturn a mountaintop mining permit that had been issued by the Army Corps of Engineers. And that resulted in a legal battle with the Corps of Engineers and the mining industry on one side and EPA on the other side that went all the way up to the US Supreme Court, which ended up confirming that EPA did indeed have the authority to take that action. A bit of a landmark case concerning mining in the US. Another thing our analysis revealed was a very steep increase in the amount of land area that had to be disturbed to mine a metric ton of coal. And that is, this chart is essentially the harbinger of the death of coal mining in Appalachia. This steep increase in land and rock that needs to be moved. But it's also a sign of the accelerating environmental impact with consequences for habitat and species throughout Appalachia. And here's the most recent peer-reviewed paper that came out of this work that actually revealed that the U.S. Fish and Wildlife Service, in ignoring that impact, even though it's well documented, actually appears to be violating the Endangered Species Act by not taking action to protect downstream species, particularly aquatic species that are on the endangered species list and are imperiled by this continued mining activity. Moving on, of course, mining happens in a lot of places around the world. Here's a satellite image showing an area in the Amazon rainforest of Peru called Madre de Dios. You see pretty deep intact rainforest here in 1984 and river networks with exposed sandy and muddy river banks showing up as sort of bright yellow. Here's what the area looked like after a couple decades worth of uncontrolled, unauthorized gold mining, small scale gold mining carried out by thousands of miners in the region. And what you can't see is the cyanide that they're using for these mining operations that is traveling hundreds of miles downstream into indigenous territory where people rely on the fish they catch and the water they drink out of those streams. So this is a kind of apocalyptic impact happening in the rainforest. We're developing automated techniques to, again, measure the changes that are happening and the growth in the impact from this mining activity to help our partners like the National Park Service of Peru identify areas where they may want to take intervention and send out patrols to stop this unauthorized mining activity. We're using a couple techniques. One is our own bespoke model that we've built. You see the results on the left. On the right, we're experimenting with a new product from Google called Dynamic World that analyzes satellite imagery at 10-meter resolution on a monthly basis to produce maps showing changes in land use and land cover worldwide. This is an astonishing data set that we're just starting to experiment with, and we think it's got great potential as a tool for monitoring ecosystem and habitat change globally on a consistent basis. And we're also using it to detect not just mining activity, but things like oil and gas drilling sites. Here's an example from the Permian Basin. The results aren't necessarily so interesting here because we have great publicly available data, at least if you can afford to buy it for Texas, that will show you exactly where all the drilling sites are. But for much of the rest of the world, there's no publicly available information on where oil and gas drilling and fracking are taking place. So we see this as a tool to be able to help monitor drilling when it's happening in and near places like, for example, the Okavango Delta that may have a high degree of environmental sensitivity. One of the other aspects of oil and gas drilling that is starting to get a lot more attention is natural gas flaring. I think since 2012, we've had an interactive map on our website that is updated globally once a day using satellite observations that we process to show natural gas flaring from oil and gas drilling sites and other facilities globally. Here's the global view. If we zoom in a little bit, we can see flaring in the US, clearly highlighting plays like the Bakken Shale in North Dakota, the Permian Basin in the Texas and New Mexico border region. And I think that's the Eagle Ford play west of Houston, showing up very clearly.
That's correct, John.
Yay. Got it right. Zooming in a little, again, here's the last 2 weeks worth of flaring activity detected in the Permian Basin. We have a companion map to the just the flaring events that we detect. This is a map showing estimates of the volume of natural gas flared from tens of thousands of documented flaring locations on the ground. We don't produce this. The Earth Observation Group out of the Colorado School of Mines produces this, but we put it on a map so people can see it and interact with it. And one thing we allow people to do is get a report summarizing the volume of natural gas flared, either for an individual facility, an individual circle on this map, or they can draw a polygon around an area to capture it. And in this case, I have drawn a box around the flaring facilities in the Permian Basin to get this, again, satellite-based estimate of the volume of natural gas flared. This is really important because the estimates coming from operators and producers on the ground have been shown to grossly underestimate the actual amount of natural gas flaring that's occurring in places like the Permian Basin. So getting independent gut check measurements like this is an important part of kind of ratcheting up the pressure so that governments and industry will be a little more transparent in their accounting methods and perhaps adopt some of the newer available technology to come up with actual measurements rather than just estimates of their flaring activity. But from a climate perspective, you could say flaring is what you want to have happen to methane, right? It produces CO2, which is not great for climate, but it's far less bad for the climate than just directly venting that methane into the atmosphere, as we see happening here from a blowout at a well in Ohio a couple of years ago. So being able to actually detect these direct emissions, fugitive emissions, and even intentional venting of methane from facilities around the world is a really important part of solving the climate challenge. I'm happy to say that satellite technology to directly detect methane emissions and venting, that technology is developing very rapidly. Here's an example from one of the commercial companies that's operating several satellites that caught a venting event from an individual well pad in the Permian Basin. There's a nonprofit organization called Carbon Mapper that is building and launching a fleet of, I think they have plans for a few hundred satellites to continuously monitor the Earth globally to detect and measure these venting events so that hopefully we can start pinpointing those super emitters out there and apply pressure to get those leaks fixed and that venting shut down. That's a really important step in the short term for getting a handle on climate change. Well, so shifting gears a little bit, what about the other 70% of the ocean? Well, we use satellites, so we can see things happening far over the horizon out in the ocean, and I'll show you a little bit about the work we're doing there. And it's not just imagery, it's other forms of satellite collected data. For example, vessel tracking broadcasts that are sent by ships at sea using a system called the Automatic Identification System, AIS. It's actually a collision avoidance system where ships frequently broadcast their identification, their exact position, the direction they're moving and the speed at which they're moving, and all kinds of other information about the vessel. These are open public systems. They're designed to be collected by other ships out on the ocean. so that they know they have situational awareness, who's around them. And it's also capable to collect these broadcasts with orbiting satellites that have radio receivers on board. And so there's this growing constellation of satellites built and launched to do just that, collect these public signals and package the data and sell it commercially. This map shows 1 year's worth of this AIS collected data. And this truly is big data. You can see that there are hundreds of thousands of ships throughout the course of the year broadcasting on this system, broadcasting terabytes worth of AIS data. And we can see it's busy out there. There's a lot going on out in the ocean. But one of the things we're really interested in is not the cumulative picture, although that is interesting and a bit alarming, but the individual picture. So here's an example of what you can do by using AIS broadcasts to reconstruct how an individual vessel has been moving out in the ocean. And from that, you can see some really interesting patterns of activity. This happens to be a fishing vessel, and we can see how it changes from straight line, point A to point B behavior, to slow down, put gear in the water, and start going back and forth, combing the water for fish. This was a revelation when we discovered that we could actually use this data to identify exactly when and where fishing vessels were putting gear in the water to fish. Before that, there was no independent way to know that. We just had to rely on the vessel captains to accurately report that information to national authorities when they came back into port. Well, now that we can track that and actually see when and where a vessel is fishing, that allows our analysts like SkyTruth's Bjorn Bergman here on a Sea Shepherd vessel, monitoring the Chinese squid fleet off the waters of Chile. It allows us to see if people are up to no good. And we had a very highly publicized example where after midnight one night from the office in Shepherdstown, Bjorn was sending messages to the Coast Guard of Palau to direct them as they chased down a Taiwanese fishing trawler that had been fishing illegally in their waters. And he guided them to an interception just 10 nautical miles from the Palau frontier, at which point this vessel would have been scot-free. That was a major success for Palau. They were able to levy a large fine and put the fishers on notice that their activity could now be watched. It also allowed us to work with journalists investigating what's going on out on the high seas that has previously gone unremarked and unnoticed. And one of those things that came to light from this investigation we did with the Associated Press was the revelation that many vessels in the fishing fleets are actually using essentially indentured servants, human bondage, as a way of cutting costs as they operate out in the ocean, catching the tuna that ends up in our markets. So that was a major impact of our ability to use this data to track fishing activity in the ocean. But we only have one Bjorn Bergman. We don't have the budget to hire 10,000 analysts to be using this data to its full potential. So we've turned to an artificial intelligence technique called machine learning that's being used to help, for example, develop driverless car technology, to scale our ability to recognize patterns of interest in data sets and also in images. And once we've done that, analyze all the images that are coming in from space to alert people whenever we see one of those patterns of interest. So we've had success automating the detection of fishing activity and taking it even farther, being able to identify not only what the fishing activity is happening, but identify the gear type that's being used. That's information scientists can use to predict what species are being targeted by that fishing event, and also to do analyses based on the amount of time the fishing gear is in the water and the size of the vessel that's doing the fishing. They can analyze whether that fishing activity is actually economic. And if it's not economic, identify vessels that must be cutting corners to save money. And again, one of the corners they cut is to not pay their crew. So we've got researchers actually developing models, risk models for individual vessels, quantifying the risk that they may be involved in human slavery in their fishing activity. That also allows us to do this. And if you go to globalfishingwatch.org, this is one of the projects that I'm most proud of, a partnership with Google and an ocean conservation group called Oceana to build this artificial intelligence, analyze the 40 million or so new AIS points that we collect every day, and put all of the commercial fishing activity on a map. Every bright light that you see on this map is a place where our model has determined a fishing vessel has put their gear in the water to fish. So turning back to one of the issues that's vexed me since the beginnings of my remote sensing career, and apparently it's vexed John as well, is this problem of mystery oil spills washing up around the world every day, hitting somebody's beach somewhere. And we know when this happens, this came most likely from a vessel passing by out in the ocean that either had a serious mechanical problem or was intentionally discharging untreated oily bilge wastewater directly into the ocean. Or if it's a tanker, washing out the cargo holds and flushing out the heavy oil residue that builds up in a tanker under normal operations. In either case, those types of discharges from vessels have been illegal under international law since John and I were wearing bell bottoms in the early 1970s. In the past, whenever this has happened, we've just kind of thrown up our hands and said, well, some ship went by hours ago, days ago. We have no way of knowing who. There's nothing we can do about it. I'm happy to say things have changed. I'm happy to say that because this is an even bigger problem than we thought. A paper came out in Science in March, looking at 5 years worth of satellite radar imagery, detecting all the oil slicks, and summing that up, identifying an area of ocean 3 times the size of France being directly impacted by oil slicks at sea. And in many instances, this is illegal discharges from big cargo ships and tankers. Here's an example of what this looks like. This black and white satellite image is a radar satellite image off the coast of Indonesia. The land area is bright, ocean is medium gray, and that dark streak with the bright spot at the end of it is the kind of what we call a canonical example of oily wastewater discharge from a large ocean-going cargo ship, the bright spot at the end of that dark streak. Well, through our partnership with Global Fishing Watch, we have access to this tremendous global daily AIS broadcast data set, and we're able to do this. We're able to match AIS broadcasts in space and time with the vessels and the slicks that we see on these satellite images. And that gives us the ability that we never had before to point fingers and name names, to, in many cases, identify the sources of the pollution, and therefore the vessels, operators, and beneficial owners who are responsible for polluting seas around the world like this. This is a project we call Cerulean. It is our flagship project right now. And again, we're working to automate the detection of these oil slicks and the correlation with AIS broadcasts to send out alerts to anyone who cares to be notified whenever our system detects an oil pollution event like this. We think this is an accountability mechanism that is required if we're going to hope to bring an end to this kind of egregious ongoing pollution at sea. Over the first year of operation, we've processed nearly 500,000 radar satellite images, scanned those for oil slicks. Our model cranked out about 3,000 instances where it thought it saw an oil slick. Our expert analysts at SkyTruth reviewed those and found about a third we confirmed were actually oil slicks from vessels at sea. And in about 200 cases, we were able to identify the vessels. This is what this looks like on a map. Every bright spot on the map is one of those detected and human verified oil slicks from a vessel. With red shading, we've kind of highlighted the fact that, yeah, it's a big ocean, but this is not an evenly distributed problem. This is an intensive chronic oil pollution problem in some particular parts of the ocean, including Southeast Asia, where we happen to have some heat resilient coral reefs that are extremely important for us in terms of potential tool for repopulating coral reefs that may not survive global warming over the next few years. Of course, it's not just oil coming from vessels that's a problem. In parts of the world, especially places that don't have the strict zero discharge regulations that we have in North America, we see chronic oil slicks from offshore platforms. This pair of slicks comes from 2 oil platforms off the coast of Nigeria. All of the red triangles show another data set we're developing using the same satellite imagery. We're identifying all the fixed infrastructure out in the ocean, all the big hunks of metal standing above waterline. That's mostly oil platforms, wind turbines, and some large offshore aquaculture operations. And that's a data set that's going to allow us to discriminate oil slicks from vessels from oil slicks coming from stationary sources like oil platforms. Here's what a preliminary version of that offshore structures data set looks like. Take it with a grain of salt. There's a lot of things in here, including some false positives that we're working to weed out as we improve the data in our model. But it will allow us to do things like this, showing the cumulative oil pollution footprint from offshore oil platforms. In this case, 4 platforms off the coast of Trinidad. We see a year's worth of detected oil slicks, the colored polygons that look like jellyfish. That also allows us to do some math to conservatively estimate the oil pollution flux coming from these platforms and the cumulative oil pollution load that they are putting in the waters of Trinidad and Tobago. This work, Cerulean, has already had some media impact. For 8 months, we worked with a nonprofit investigative journalism team based in the EU. When they saw our data, they decided to do an investigation of the problem of chronic oil pollution from shipping in EU waters, something that really had not been recognized before their series of articles and report came out earlier this year. That's the meat of the presentation. I think if you don't mind, I'll just follow up with a few slides quickly because I love satellite imagery. I've been doing this since the early 1990s, and I'm always kind of like a kid at Christmas when I get a new data file and I open it up to see what that patch of Earth looks like. And I think in many cases, satellite images are just a perfect tool for conveying the complexity and beauty of planet Earth. So here's just a few of my favorite examples. That last was a delta in Madagascar. Here's a dust storm racing across the Sahara, inland delta in West Africa with linear sand dunes. And my all-time favorite, these are sand waves on the seafloor in the Bahamas, seen from space, in water that I think is about 50 to 100 feet deep. just gorgeous, reminding us that it's a beautiful planet and motivating me every day to keep working on doing what I can do to help save it. So thank you very much, folks.
So thank you, John. That was very interesting, especially the last one of your last slides, the one of Trinidad, which I used data like that while I was still at Shell to try and calculate the variation of ocean currents in the Gulf of Mexico through the year. But if anybody, I hope people have lots of questions. So you can either put them in the chat and John will open up his chat and read them, or you can raise your hand. Now, while you're thinking of questions, I will ask John, is there anything in the chat, John? I lost it for some reason.
There's one in there now.
Okay, good. Go ahead.
How do you access the SkyTruth maps? Yeah, thank you. We have a website, skytruth.org. That's definitely the starting point. Some of the maps that I showed are, available through that site. Right now, the Cerulean project has an experimental map interface that we've built. If you'd like to see that and look at the oil slicks that were detected during the first 2 years of the operation of our prototype, I'm happy to actually send you the link. So if you don't find what you want on our website, don't hesitate to reach out to me directly. I am John at skytruth.org. And the flaring maps, we have a flaring web page that will lead you to the maps and also lead you to a pretty thorough explanation of where we get the data from and what we do to it before we put it on the map. And that's important in terms of, understanding how to interpret and use the information on those maps. So yes, I would encourage you to look at the website. We have an area called Toolkit that lists some of the major projects and products that we produce. It's a bit of a sandbox to have fun and look and explore the things that we've been doing. But again, if you don't see what you're looking for, don't hesitate to reach out and ask. What type of resolution exists for methane detection? That is a great question. It is getting better. I don't know if I know the exact number yet. One of the workhorses for this in terms of free public data is again coming from the European Space Agency, from their Sentinel-5 satellite. There's an instrument on that satellite with a long acronym that shortens to the word TROPOMI. That is good for kind of regional detection of methane in the atmosphere at the level of detail of, say, a particular oil field, not at the level of detail of an individual drilling site or facility within that field. But the example I showed you from a commercial company called GHG Sat, and that's one of a few commercial companies now that are operating at this level, that does have the ability to detect plumes that you can pinpoint to an individual drilling site or facility. And the Carbon Mapper constellation that I measured, it too will have that ability. So I believe that's measuring methane concentrations at the level of about 50 to 100 meter pixel size. Don't quote me. I'm not up to speed on what it is they think they're going to be able to hit in terms of resolution. List a few universities that offer GIS degrees. Yeah, well, I taught for a while at George Mason University in Fairfax, Virginia. They had a great GIS program. I think Johns Hopkins does, West Virginia University. I'm sure Texas A&M. I think pretty much every large university now has at least an earth sciences and geography department that will have GIS coursework. And many of those will also have geography degrees. And I think that's usually the degree program under which GIS can be found. So I think you'll have no trouble finding a lot of potential programs out there.
From mapping, that's in response to the ice mapping question, John.
Yeah, that's a great question. Thin sea ice is a source of false positives for our oil slick model, especially polynyas, so thin new sea ice that forms between sheets of older ice that are breaking apart. You get a thin linear patch of smooth ice that looks very dark on radar satellite imagery. So we're looking forward to more advanced radar, multi-frequency, multi-polarized radar imaging systems that are coming over the next 2 to 3 years that should give us the opportunity to discriminate sea ice confidently from oil slicks in polar regions. This is acutely interesting to people as the sea ice retreats in the Arctic, and shipping activity and oil exploration and production activity increases in the Arctic. So high interest from our team in being able to tell those apart. There are lots of ice mapping products that are publicly produced using the European Space Agency's Sentinel satellites. And there's a company based in Finland, I think, called IceEye that also operates a fleet of radar satellites primarily for ice mapping for commercial vessel fleet operations and other commercial clients. We do not access hyperspectral data yet. The fleet of satellites that's being built for Carbon Mapper to measure methane is going to include hyperspectral instruments. And we're not sure what the spectral range and the bandwidth and band resolution of those instruments is going to be. They're still in development, but that is coming to space fairly soon. Right now, there's not any consistent, reliably accessible, free hyperspectral imagery from space that we've been able to get our hands on. There's been an instrument on the space station off and on, but it hasn't been something that we could make regular operational use of. So we're looking forward to that again in coming years. Great question. So we detect this oil pollution off Trinidad. So what? That's a question that applies to many countries around the world where we see these pollution events. I think I showed a slide showing where SkyTruth fits in the conservation landscape. We rely on a network of partners to take the information we produce and do what needs to be done to create change in the world. One set of those partners are climate and ocean conservation advocacy organizations like Oceana, like Greenpeace. So we're working with them to use our information and use it in ways that they can apply pressure on national governments to pay attention to these problems. And that pressure can come through a variety of pathways. One of the most effective actually is just media attention on the problem. So we and our advocacy partners often work with media outlets to get them to cover stories and use our data to raise attention to the issue. But we also work with nonprofit groups of nonprofit attorneys And they have some other ways of applying pressure. One is directly on the companies that are identified as responsible for these pollution events. The other is, again, working through national government agencies to make them aware of these problems, to identify the polluters, and to encourage the agencies to take action based on these findings. So I'd call it a work in progress. And it's often we have to rely on these partners because it's not particularly obvious who you call or who you notify in coastal nations around the world when a pollution event is detected. It takes a lot of legwork to build the networks locally to understand how to do that reporting effectively. Yeah, that's a great question. Sea surface depressions identified by interferometry. Yeah, actually, I am not familiar with that, but I am familiar with using gravimetry, satellite gravimetry, for identifying basically the lumps and bulges in the ocean surface. That was identified as a tool a couple decades ago, maybe earlier, for identifying offshore sedimentary basins, but also identifying major offshore ocean currents. I haven't seen any correlation between those highs and lows and the oil slicks that we've been detecting. It's a good question, though. We should look at that and see if we can do any correlation. One thing we have done is we've brought in data, other data showing where currently producing offshore oil and gas fields are located. That's kind of a primary filter for us. If we see slicks in those areas, then we need to look harder to identify whether it's coming from a vessel, coming from a fixed piece of infrastructure, or in some cases, we don't see any hardware at a location where we see a chronic source of oil pollution. Then we know we could have a natural oil seep in that area. And so for the offshore oil basins, offshore oil seeps are on our radar as a potential source that we should be aware of. Calling the spokespeople in the PR company, PR division at the oil company. I think for some of the more proactive companies that are getting serious about making public measurable commitments to sustainability, I think there could be an opportunity there. And actually, I see it more obviously in the shipping industry with big fleet operators like Maersk that have made pretty strong public commitments to reducing pollution from their fleet operations, moving toward zero emissions shipping. These are statements they're making to their shareholders, to investors, as well as to the general public. I really think there could be opportunities to work with companies like that who are willing to expose their fleet operation to the world and say, okay, here it is. You can watch it in near real time. We know we still have problems, but we're working on them. And you can also compare us to our competition who are not making these statements and see how well we're doing relative to the other guys. I think there's strong potential beyond government action or regulation to solve some big global conservation issues using this kind of lever. And so we're looking forward to finding opportunities to demonstrate that.
John, I have a question. Do you, on a totally different topic, do you, and I'm sure you have, given serious thought to the privacy issues and other ethical aspects of how you're using satellite data?
That's a question, John, that we get asked on a fairly regular basis.
Yeah, I thought you would.
And it's the answer I have today might not be the right answer tomorrow. I'm not trying to weasel out of answering that question, but it's just because the technology toolkit is evolving so rapidly. So, when you and I were doing this work at Earth Satellite Corporation, there were so few tools available, and the resolution was so coarse, and the data were so scarce and expensive that privacy concerns were just kind of amusing to think about, right? It's like we don't have anywhere near the capability that where anybody should be concerned. That has changed quite a bit. So, now we have commercial imaging satellites in orbit. Anybody can buy an image from them with a credit card and have it show up, the next day, or if not sooner, and at 30 centimeter resolution. So pixels the size of, a dinner plate now. You can see a lot with that, but you still can't quite see individual humans, certainly not to identify them. You can see human equipment, and you can see that it's there, right? So a satellite image is still just an instantaneous snapshot in time. And so, I can see construction equipment on this site in what is supposed to be a protected area with no construction activity. I can't say much more about it than that, right? So we're getting closer, and there certainly are concerns when you are using data sets that allow you to identify individual actors, like the vessel tracking broadcasts. But again, that's a public open system. It was designed that way on purpose. When commercial companies are launching satellites to collect that data, commoditize it, and sell it, I don't have very many concerns about being a consumer, buying it, and using it to track activity out in the public spaces of the ocean. But this is a question that we're going to have to continually confront as the technology evolves. Once again, we're in a situation where the technology is racing ahead of society's confrontation of the ramifications and consequences of that.
Yeah, while you were speaking, I was thinking that you probably, the resolution to those kind of issues, once the technology is developed to that point, will be more a matter of society coming to a consensus about how the data should be used. Right now, virtually everything you see is carried out by some sort of organization and sort of that operates under some sort of societal framework. But when it gets down to the individual, we're going to have to decide what's permissible and what's not. Anyway, there's another question on the chat here.
Yeah, I just wanted to follow up on that, John, because anybody can do this now. And when the BP oil spill happened, we were one of the only entities out there publishing satellite imagery, doing our analysis of it, delineating the oil slick, making calculations based on that. Now, anytime an oil spill happens somewhere, SkyTruth is like the last one to the party. There will be dozens of individuals on social media throwing satellite imagery out there, analyzing it. And now the problem is, sorting the wheat from the chaff in the media space, in the social media space. So you'll have all kinds of people publicizing all kinds of crackpot analysis that is not correct, right?
No,
so increasingly, I see a role from entities like SkyTruth as not being the first to jump into the fray, but coming in with a more careful analysis after we've had a little bit of time to think about it, and maybe being able to, inject a little sanity into the inevitable chaos that we find ourselves in. And there's that makes me also think of the privacy question. We're in a world where the public has been conditioned to give up privacy and the expectation of privacy in exchange for getting free stuff.
Yeah.
And that is the premise of social media right there. And, Elon's trying to get people to pay for it now. We'll see if that works or not. We'll probably know pretty soon. But the privacy considerations need to be kind of navigated and discussed within that context. What really is society's expectation of privacy in the world that we live in now? I don't like that world personally, but I do like free stuff. So it's tough. The last question I see here, I love this. Is there an effort to assess the quality and quantity of reclamation? Thank you for asking that question. I didn't get to that in the presentation, but our mountaintop mining work is actually pivoting now to using satellites to measure reclamation success over time. And that's work we're doing right now with researchers at Colorado State University in Fort Collins. I think we have one paper. Actually, I believe that paper in PLOS One that we co-published with Defenders of Wildlife, that I think that actually used some of the reclamation data that we're beginning to produce. And that's an area where I'm really excited. Not just abandoned mine land recovery, but can we use it as a tool to compare and contrast different reclamation requirements, different reclamation and restoration management strategies, and then possibly even look at, again, companies that are going above and beyond the minimum requirements and are taking on additional investment in landscape restoration. Can we see and demonstrate that? Because I have a dream for the mountaintop mining region. This is a huge area that's been disrupted by mining activity. I think it is ripe as a demonstration platform for investment in landscape recovery to improve the carbon sequestration performance of that land by restoring some functionality, some biological functionality to these landscapes. And if you can do that, and you can measure the carbon sequestration result of a given level of investment, then you may have a tool to incentivize companies to do carbon offsets and help rebuild the Appalachian landscape to some level of stability and ecological performance, societal performance that can help Appalachia turn the corner toward a new future. That's kind of a dream that I have. Even though I live in New Mexico, my heart is still in West Virginia and kind of in coal country. So we're excited about that potential.
Okay. Our hour is up, but are there any more questions out there that anybody wants to ask?
I want to thank you all for sticking through the hour with me. And again, if any questions come up afterwards, please don't hesitate to ping me, shoot me an email. If you forget my address, we're hello@skytruth.org, and it'll get to me. I would just love to have your thoughts and any insights you might have and want to share with me to help us do a better job at looking out for planet Earth.
Happy birthday!